Hello, everybody. Thank you for joining us today. Whether it's morning, afternoon, or evening for you, we're really excited you were able to take an hour out of your day to join us for this incredible webinar collaboration with Miro. I can see people are already in the attendee chat, joining and telling us where they're from, but as we give people a few more minutes to hop in, if you just want to be in the attendee chat and tell us where you're from. I see Texas, Hungary, Argentina, Romania. I myself am in Denver, Colorado, and weirdly enough this year we have not gotten snow, which I think this is the first time in it's one of only 3 times in the past 100 years, which is kind of crazy. Where are you guys joining us from, Tim and Michael?
So I am from the sunny Amsterdam, obviously pun intended.
And I am in Edinburgh, Scotland, which right now is without sun, but only for the past hour or so.
Not too bad. All right, let's go ahead and dive in. Hello, everybody. My name is Molly, and I am a member of the team at Scrum Alliance, and I am very excited to welcome you to today's webinar presentation, Engineering Superpowers Unleashed, 2 proven frameworks for cross-functional excellence, hosted in partnership with our wonderful mission sponsor, Miro. Before I hand it over to Michael and Tim, who you're really here to hear from, let me go through a few quick things in case you haven't really familiarized yourself with Scrum Alliance, or maybe you have a certification and you know who your trainer is, but you're not quite sure who Scrum Alliance is. We are a first of our kind, not-for-profit, serving a global community of professionals, and we partner with world-class trainers to provide in-demand professional certifications. We were established in 2001, and since then we've issued close to 1.9 million certifications. And our mission is to advance real-world agility by equipping and inspiring the change maker in everyone. If you are a Scrum Alliance member or you're looking at becoming a member, you get access to some really cool member benefits, including some discounts and special offers, tools, career advancement and community opportunities, as well as free resources throughout the Scrum Alliance website and events such as this. And in particular, one member benefit and partner I want to highlight is today's host, Miro. They joined us this year as our mission sponsor, and together we're equipping professionals and teams across the globe with skills and tools that drive agility, foster collaboration, and unlock innovation. We have some exclusive member perks from Miro, including some discounts. And if you keep an eye on your inbox over the next few weeks, we have a few more exclusive member benefits with Miro coming out. Before we dive into the presentation, I wanted to give you a quick tour of your webinar console for today. The first thing we're going to be calling out is the Q&A box. So throughout the presentation, if you have any questions for Tim or Michael, or you have a technical or logistic question or a question about the Miro product, please put it in the Q&A box on the left-hand side of your screen. Next, we have our related content section, and you can find a link to today's Miro board where you can follow along with Tim and Michael as they go through the presentation. We also have the attendee chat, which I think most of you have found at this point, but if you haven't, it's right in the middle of the screen underneath our video stream. And finally, we have an emojis feature. As we go through the presentation, please hop in with some emoji reactions so we can get a gauge on how we're doing. If anything stands out, it gives us a great idea of what content really resonates with our audience. A couple final notes. This webinar is being recorded, and you'll receive a link to the on-demand recording sometime tomorrow. Depends on how long everything takes to process. And if you're a Scrum Alliance member, in that email will be a link to auto-claim your Scrum Education Unit for attending this webinar and continuing your Agile journey. That is all from me today. And so I'm going to hand it off to Tim and Michael, 2 members of the team at Miro, for the presentation that I know y'all are all here for and excited for. Tim and Michael?
Thank you, Molly. Okay, I'll take over. Give me 1 sec, I'll start sharing my screen. Hi, everyone. It's great to meet this diverse audience today. I'm going to take you through the ways of working that we've introduced at Miro a couple of years ago. And it did improve not just our pace and delivery, but also the overall company culture, I would say. And then I'll pass it over to Tim to describe one of the practical methods to actually optimize the end-to-end delivery as well. So first of all, a little bit of context. So the Miro story, for those of you who may not have heard of this company. So we started almost 15 years ago now, back in 2011, as a company that was called Real-Time Board, that was focused on digital whiteboarding. And in the recent years, especially during the pandemic, we went through a massive hypergrowth phase, where basically within a couple of years, the user base grew almost like 20 times, and we rebranded as Miro, and eventually moved on to where we are today, which is over 100 million regular users. We've also re-platformed the product from just a basic digital whiteboard to what we call an AI innovation workspace, which powers up multiple vertical use cases and products, not just the whiteboard collaboration. And we're maturing as an enterprise solution and unlocking the team performance with AI. Why did we have to move to this new ways of working? So what was holding us back? Essentially, we were experiencing during the hypergrowth, our team grew very fast, and we added quite a bit of complexity. And what it led to is, because of all the layering, our decision making became super painful and very slow. The feedback loops were very slow as well. Stakeholders were not always aligned and aware, and that of course led to collaboration being siloed across the teams as well, because not everyone was participating in relevant cycles. And cross-functionally, for example, engineering and product even were not working closely together as they should, letting alone other functions that should be participating in the delivery process. And of course, that led also to mismatched expectations. And as a result, the value delivery overall was quite slow. So what we did is we focused really on consistency across the board. We introduced the new of working, and so we made sure that there is basically consistent ownership across all teams and all functions. There's proactive understanding and sharing of milestones with information being provided asynchronously on as needed basis. There is space setting, which we're deliberate about. Basically, we always have the next date or a date for a date, which is key. Because it's not just setting expectations, but also allowing other functions to understand how they can plan around those expectations. And we fully embraced imperfect moments for early feedback and flexibility. So we're not working on massive enterprise decks, but rather the moment there is a first draft that we call bed version, it's completely fine to share it. And that has allowed us to speed up massively. So our methodology has been discover, define, and deliver, and that basically is a simple way to say that that's how we formalize the discovery process of what problem we're solving, why and why now, then define, that is essentially gathering all these requirements, formalizing them, and defining what exactly we're proposing as a solution, and then the delivery phase, which is the obvious one, where basically we work on the product or a feature that is then released, and then this endless loop repeats because we get the feedback from the market, and we continue to iterate and optimize. The way it looks in practice is basically there is a number of practical endpoints and artifacts here, or touch points and artifacts, I should say, that we go through, and we also have a number of features in our platform that allow us to go through that in a methodical way. Now, going to the ways of working, which is a very simple framework. Essentially, it starts with the kickoff, which is at the discovery phase. We define what problem we're solving, why it's important, and why it's important to work on this now, which is one of the key questions, because there's plenty of problems to solve, but why now is is something that if you cannot answer today, then it usually means that it's not important enough to work on it right now, among other priorities. Then we go through the solutions review, which includes the hypothesis on a few proposed solutions. It includes a clearly defined RACI, so responsible, accountable, consulted, informed, which is a framework to basically define who needs to be present in which types of decisions. And then once everyone is aligned on the proposed solution, we go into the delivery phase, which before the actual before public beta, at least I would say, before the general availability release, we go through the pre-release review, align on the metrics, align on the success criteria, make sure that all of the cross-functional partners are included as well, not just engineering, product, and design, but also product marketing, customer success, GTM organization. And at that point, everybody is fully aligned on any type of enablement material. And so then the feature gets launched. Then we collect the signals from the market and do a formal post-launch review. And then if necessary, we go back and iterate on that. Now, the principles are important here. What I already mentioned is that those milestones are checkpoints and not gates, meaning that they're not like you don't have to go through a physics defense to actually justify a move to the next step. So it's a very lightweight preparation. You should always have the next date, i.e. if we've just done a kickoff, then the date for the solutions review, or at least the date when you will announce the date for the solutions review, needs to be defined right away, ensuring the right RACI. And we also encourage sharing async first when possible, so that people can consume this information asynchronously, prepare questions, and really keep the synchronous meetings to a minimum and keep them efficient. Now, this is an example of what a kickoff template looks like. So problems to solve, why and why now, then product and business scope, so initial point of view on the problem space from the owning team, then key stakeholders, operating rhythm, so how we will work together, so who needs to be involved, which functions, and what the cadence will look like. If at that point what success looks like is known, then try to define at least the first draft of that. And then any type of user research, dashboards, metrics that support the hypothesis should be provided as well, if available, of course. The output here is typically a very lightweight project in our project tracker. We use Slack, and we usually create for any structured initiative, we have this I project name, meaning initiative project name type of Slack channel. They're public, and that is also important because going through these phases, sometimes we need to expand the RACI, sometimes we need to add more people, and we really encourage transparency, and that makes it easy. And then usually there is an async artifact that's recorded. So we have a feature called talk track, which is basically an equivalent of Loom on Miro, that is being shared. And yeah, like I said, a date for solutions review. So that's just an example of one milestone. I'm not going to show all of them, but like I mentioned, as we move forward, there's more and more details being added to the initiative. And I wanted to show you how it looks like in practice with Miro as a tool. And we are really big on dogfooding or drinking our own champagne. We use Miro to build Miro every day. So this is really more of a formal view of what problems we're solving today in this kind of AI/agentic world. So one of the problems is that because there is no proper alignment on the problem space, usually a lot of companies end up, or a lot of teams end up solving not the right problem really, or pivoting along the way because they just don't invest enough in discovery and definition phases. The other one is lack of context in agentic coding tools. So it's basically garbage in, garbage out type of problem. And then losing sight of company goals, so not being able to attach the initiatives or the problems you're solving to the overall strategy. That I've seen it personally many times in my career. And then siloed execution obviously is what kills the speed and quality. So we use Miro to streamline the overall delivery process. This is how it looks like more visually. So in large blocks here, basically we're talking about being integrated into the systems of record, like Jira's of the world or other ticketing systems. And also we can ingest basically stats like user sentiment and different metrics from various systems like Salesforce. Then all of that is basically digested and refined and presented in the form of insights. Then we work in the solution space where the team can ideate on the solutions and refine the ideas with the help of AI, of course, and I'll show how it looks like a little bit later. Then we can easily prototype the solution and move on to the to a spec, which then using an MCP can be exposed to code gen tools like Cursor and others, and that's how we accelerate essentially the delivery phase. I wanted to pause quickly on the delivery phase here, given the audience. So what we're solving in the delivery phase specifically is the problem of context. So having the proper requirements in place, non-functional requirements included, having the spec that is up to date and reflects really the platform and the code base, and also having the architectural alignment between different teams is key. And because we're limited in time, I'm going to show you a quick 3-minute demo. Not a demo, but rather a video that captures the demo that shows how all of that works together.
AI coding tools can now generate production quality code with a single prompt. The key? Comprehensive live context powered by MCP. That's what Miro Specs delivers. It provides live project context directly to your AI coding agent. Let's see the results. On the right, we have our AI-generated app running on localhost. On the left, we have our prototypes that our designers drew up. You can see the app is pixel perfect, exactly matching the prototype on the left. Now let's understand how we got to this point. As your team moves from idea to design, they're building a rich, shared understanding. From the high-level product brief, goals, and user stories, to the pixel-perfect visual designs, and the robust technical architecture that ensures it all works together. Now, let's take a look at how an engineer uses Miro Specs to enable their AI coding tool to get all the relevant context. First, they start by checking the sprint plan to pick up the next highest priority task. After reading the Jira task, they start collecting all the required context for delivering on their task. Instead of just a Jira ticket, they now have the complete spec. It already includes foundational company context, coding standards, accessibility rules, security guidelines, ensuring nothing gets missed. And of course, the critical project context, the PRD, the technical diagrams, the user flows, the what, why, and how of this feature. And because this all lives in Miro, the entire team, product, design, engineering, collaborate to ensure the spec is perfect. This transforms AI development from a solo, disconnected task into a truly multiplayer experience. Now that the team has agreed that the spec is complete, it's time to pass this task to AI. It's as easy as pasting the board URL in Cursor or your AI tool of choice and asking it to implement the content on the board. And here's the result. On the right-hand side, you can see the AI-generated live app running on localhost. The software works and looks exactly like the spec. The authentication providers and the visuals all implemented correctly because AI had the complete context. But it doesn't just stop here. This is a two-way street. Based on the complete context, including the code AI just generated, the AI can create new artifacts and add them right back onto the spec. Your spec evolves with your product automatically. This is the power of Miro Specs. It's not just about converting your designs to code. It's about making your team's shared understanding the ultimate source code. We're closing the gap between vision and execution. With Miro Specs, your context is now executable.
Great. Yeah, hopefully you enjoyed that quick snapshot of how we do it at Miro. Tim, do you want to come online?
Hello, hello. So I'm not quite sure how I get my screen to show up. I think maybe you have to stop sharing. I don't know.
Let me do that. Yep.
Oh. Just a second. There we are. How are you doing?
Doing all right. How are you?
You talked about early on, you'd mentioned something about handoffs and queues being things that killed speed and quality. I'm kind of curious, how did you experience that? What was that like? How could you tell?
Yeah, that's a great question. So I think it is primarily the garbage in, garbage out problem that I mentioned briefly. When there's not enough alignment on the clarity of the problem space that we're operating in and exactly what we're solving. So we end up going in, or in the past at least, we would go in trying to produce a prototype or POC of something that looked like a viable problem to solve. Then we start looking for product market fit, and it turns out that it's completely wrong assumption. And what's worse is that a lot of it could have been prevented by getting the earlier signals. And also by optimizing for this early stage of development, or rather not even development, but rather specification, so that when we go into development, it's not just about the speed of delivery, but rather the end-to-end process and the value of that process. Because in the end, it's not about the how many deliverables you've done in a certain amount of time. It's more about actually how much value have you delivered.
I think a lot of people miss that idea that it really is about getting things done and delivered. You know, there's a system that's been used by the Toyota people and lean people for quite a long time that's very helpful to examine the handoffs and the delays and the general efficiency of delivery. And it's brought us to the same end conclusion. We find out that every time there's a handoff, there's a queue. And every time there's a queue, if the person at the other end is busy, there's a wait. And we found, strangely enough, that often in a software project, work that's ready to do, work that's been started, may spend 90% of its life not being worked on, but sitting in one queue or another as it passes over time. Would you like to see what that looks like? Can you bring up
Absolutely.
a picture?
Let me share the screen
Now,
quickly.
while you're doing that, I'll mention, whenever you borrow something from one kind of an industry and you put it into another industry, that's risky, right? Because people don't do the same things. So I'm going to be showing you a picture that actually comes from factory style work. That's really a part of assembly work. And we're going to show an innovation that takes it out of that space. But it's important to kind of see how this shapes up. So there's a few different elements in this picture. And I'll move my cursor around. Maybe people can see it. Yes. The top part is about an information flow. And a lot of what you talked about was, collecting the ideas, deciding what we're going to do and how we're going to do it, getting it into the team's hands. That kind of analogous to the top part of this. We're not going to talk about that part very much, but just so you know, that's what that's for. There's another
Tim,
piece in here that...
If you're using the cursor, let me just, I'll get out of the presentation mode so that you can actually use the cursor.
It's okay. That was the blue part I was talking about. So just go ahead and keep doing as you're doing, I guess. I don't know if you can see my little cursor moving. I don't think you can. Okay, we won't worry about that. It's not important. It's not important. So the top part, the blue, supplier, production control, customer, that's information coming back from the field that we would consider. A lot of people, that's, if it was assembly, it's the dealers have ordered cars. We've decided, when we're going to make them, how we're going to make them, how we're going to ship them. Oh, thank you. Look at that. So that's not the part that we're really interested in so much today. What we're really going to be talking about more is this last two parts. The material flows in a factory, what flows from left to right. It's a bunch of different parts. And you notice that for each one of these, there's a little triangle. I don't know if you can see it very well, but there's a little tiny triangle. So stuff has come in for the first stage. Maybe it's weekly or biweekly. It goes into a queue and it's waiting for people to do that work. You have backlogs in Scrum usually. There's usually an overall backlog, and then there's a sprint backlog. And well, let's say that you aren't working cross-functionally, but you're working more traditionally, as most Scrum teams really are. Very few real cross-functional self-organizing teams. I keep waiting for that to change. It'll happen. And this might actually help it to happen. So notice that things come for code, and there's a little queue here of things coming from above. So this is sort of a product backlog that comes down. It has a population, right? And then things are going to flow from code to ready to test. You probably have that on a board somewhere, and there's a population of things in that queue, and then test. Maybe you're having scans or some other kind of work done, security. And eventually you're going to ship it out to the customer, deploy that. So if you're not working in a continuous way, you'll probably have stages, and each stage will have a queue. Every place there's a handoff, always, 100%. If there's a handoff, there is a queue. And 100%, if the person at the other end of the queue is busy, it turns into a wait. So if we take a look at the bottom, this is a visualization of things. Now, this isn't actually taken from a coding project. I don't think many of us have 733 things waiting after testing to be scanned, or 1,200 things after code waiting to be tested. I hope not. That would be a nightmare. Could you imagine? If you're in that situation, you have my sympathy. Well, on the bottom, again, this was taken from industry. So things coming in, would only wait for days. Orders coming in, maybe 6 days. And the first station, was actually, we wrote code, but there's clearly not code. It takes 300 seconds to do the work. Nothing's that quick, right? So what happens here, though, parts come in, they wait for 6 days, 300 seconds, the first stage takes care of them. They go into a queue for the second station. They wait an average of 4 days. They get picked up, 45 seconds worth of work. They go to the next queue. They wait on an average 1 day. They're picked up 240 seconds of active work later. They're ready to be shipped out to the world. That's a production lead time, which is the total time from the far left to the far right of 14 days. Now you'll notice that the weights are up high and the actual process is down low, the actual active work, right? So this is 14 days over about 600 seconds. 10 minutes. So 10 minutes of work gets done over 14 days and out the door it goes. That's not, again, software development numbers, but let's think about that for a minute. How long, what are the stages you have in your process? All right, so something is coming in, it's hitting your sprint backlog. It is eventually picked up. Now, maybe you have one queue for the whole team, and so things are taken as people get to them. Maybe you've assigned them to individuals. So each individual has to complete their current job before the next one is picked up. If they have 2 weeks worth of work, that means the average wait time is about 5 days. And the question is, could that work have been picked up sooner if it wasn't waiting for one person for an average of 5 days? Well, let's say then there's a code review afterward, right? How long does it take to get a code review? Well, most people want it to be less than a half an hour. How many code reviews does the reviewer have to do? That's a population of a queue, right? And how long they get through them is how long each code review takes on average times the number of code reviews to do. That still seems to be highly variable, but still true. And if we knew an average, we could start to guess or maybe do a Monte Carlo to figure out how long. And then if it goes on to do load testing, well, how many days do you wait for load testing? How many things are waiting for load testing? How long does that take? So we'll often find out that the programming time in a fairly normal corporate team is only 2 to 5 days. The total lead time to delivery is often on the order of 120 days. So 2 120ths were the programming. Right? So can we skip to the next page real quick here? I want to show you some of this. I'm somehow not following Michael correctly. There we are. So the numbers that it shows in the box, the cycle time, which is just roughly how long it takes you to do a thing. And again, I said, it's not unusual to be 2 to 5 days for programming. Fork is sliced thin enough. Changeover time. How long does it take for you to go from one job to another? Well, every job we do is unique. So we kind of fold that into the cycle time. Don't bother trying to track it separately. But in a factory, they'd have to change out the machines, readjust things to make a new piece. So changeover, not super useful, but it's there. We have uptime. Well, okay, how long are hours available? Well, for coding, it's all day. For testing, it's all day. Unless you have to wait on testing environments. And then what happens if somebody only does 2 hours of code review in a day so they can get 6 hours of meetings and programming? Well, that's reducing how much uptime is available for that person. And I've seen a situation where somebody was saving 4 hours a week to do code reviews. And they would often have 20 or 30 code reviews piled up because they were only available for 4 out of 40 hours, 1/10 of the time. And of course, it creates a bottleneck. Shifts, we always work just 1 shift a day. Don't worry about that. But that's your availability. We largely ignore that because people take time away when they do. So these are interesting things, but they all assume that the work flows from the left to the right and always goes through and it always works. And that's not true for us. In software, it's not like you wrote a feature, but if that feature is not good, there's another one just like it because you made 15 of them, and maybe one of them had a flaw and they're all the same feature. You can't just swap out a fender or a bumper for a different one, right? So we have a different problem. We have quality gates, right? So if I send something to a code review, that code review is a quality gate and it has a pass rate. So the pass rate is a percentage of time that items go through without rejection. Now, if you were working in a team and you had a 100% pass rate on the code reviews, probably the bosses would be angry, right? Are they even looking at the code? What are they doing? We have 100% pass rate. So often this pass rate is set quite low, maybe 80%, maybe 70%. Well, if you know what the pass rate is, then that also lets you know how much work is going to go back rejected for rework. So you'll see a pass rate. That's one of my innovations. Nobody else in industry does this, but in software, I think we need that. And if we look at that, then we also know when work is rejected, where does it go? So here we have a security scan. It only takes a few hundred seconds. We can only do them so often. There's set up and tear down on the system where it's done. Uptime is 100%. Pass rate, 95% of the time, all the code flows right through. There's no big security, no new security problem to deal with. But if something's wrong, it goes back to code. Now, this is a nice statistic system. Again, remember, the secret here is every process has a queue. Every handoff has a queue. Now, that can be called an inventory if you like to look at it as a waste. You can look at it as a queue. You can look at it as a buffer. So if I have uneven work, so sometimes a test takes 5 minutes, sometimes it takes a couple of hours, having a few of them there in case I finish fast is kind of handy. So it's a buffer. It helps me. It protects me. So I have, I don't starve out for work. But also, if there's 733 items, that's just a huge inventory of half-finished work. And that's a problem. So think about this. Inventory, queue population is committed time, right? I'm going to have to finish all the things in my queue before they can go on. And this, by the way, gives us a new view of things. think about today, a new piece of work comes out to be done. How long does it sit before it gets assigned to a sprint? How long does it sit in the sprint backlog before somebody picks it up? When somebody's working on it, who do they hand it off to? How long does it wait behind how many other things to get through that person's work, right? And you go through multiple stages. And by the way, maybe we should skip forward one more page real quick. When you look at yours, what does your lead time ladder look like? How long do things wait between queues when they're not actually being worked on, but they're not blocked? They're not rejected yet. They just haven't been handled. So the lead time ladder is a way for you to look at your process and see, where are we piling up queues of work and how long does it take new work to get done? By the way, notice, if this were the case, if it took 2 days to do the programming, but it only had a 40% chance of going through the system, that's not so grand, right? But if I could take twice as long programming to write code that will go all the way through the checks on the first try, raising the pass rates of all of those gates means I can deliver much more often. So kick over one more page. We'll show another piece. There you go. So notice here, the overall pass rate is the product of the quality gate pass rates. So this review has an 85% pass rate. The scan has a 95% pass rate. Overall, 64% of the items statistically are going to return for code remediation, or are not going to return for code remediation. Sorry, this is the pass rate. So can you imagine 36% of the work you do is rework? Does that feel particularly convenient? Well, what happens particularly here, notice that if we made it to the scan and it's rejected, it rejects to the code stage. So it comes back, past the test, back to the code. When the code is done, it has to go back into a code review, right? Because we've just recoded it. So it has to visit all the intermediate steps. This is just a little bit of math to actually figure this out. So if I put a new piece in, it's going to take a certain amount of time. It's going to wait behind a bunch of other items. That queue is going to be consumed according to the cycle time of the next step. It has a pass rate. So here, 15% of those things are going to come back to code again and wait in the coder's queue for another code for the programmer to pick it up again. If it gets through, though, it'll go down to the next scan. If it's in the lucky 95%, it moves on out. If it's in the unlucky 5%, it comes back again. Notice every time I submit it to the queue, I've got a 64% chance of getting through the other end and delivering. When people want to know, why is it that we're all working so hard? We have so much going on, but nothing's getting done. I would suggest that it's because things are waiting in queues and re-queuing for attention when they don't need necessarily to be. So let's kick over one more. There we go. This is a simple bit of math, really, when you think about it. We're dealing with averages. We know how things will re-queue. We know what the pass rates are. We know what queue populations are. So it should be possible to do some basic mathematical analysis and help find where are the bottlenecks in a system that we've studied and diagrammed. And I believe, Michael, you can give us a picture of a little AI Sidekick assistant that helps to analyze these.
Yes, thank you, Tim. That's actually quite impressive. When you summarize everything that way, it suddenly starts making a lot more sense than just focusing on the coding phase, like most companies do. All right, so I'm going to give you a quick demo.
Let me throw a piece on that before we get too far. Notice that when things take a long time to deliver to production, people at a certain level in the organization, they say the programmers are going to have to work faster. And that's because they don't know that time in development is not all programming. They don't know that there's a series of queues and waits. So they think that once it's handed to the programmer, The programmer starts working on it, and the day the programmer stops, it goes into production. So when that's 120 days for some small bit of work, at a certain board level kind of position, it looks like the answer is the programmers need to work harder and faster. But you and I know when we work harder and faster, we make more mistakes. That lowers the pass rates and increases all of the queuing in the system. So it turns out if we do a better job of programming and spend a bit more time possibly, we might be 10 times faster. Well, I'll let you go ahead and show the demo.
Great, thanks, Tim. Okay, so I'm going to show a quick demo of a Miro template that actually includes an AI assistant that we call a Sidekick that can actually automate this value stream mapping calculation. This is actually a template that you can find in the Miroverse, and it will also be shared out. In fact, you can find it on the presentation board that is already shared with everyone, and it will also be shared through an email after the webinar. So what we have here, and that's exactly what you will see once you basically launch this new template. The only difference is that we have pre-filled numbers here just to make it more practical. So the moment I select this, I have the Sidekick here on the side, which offers me some options. It can analyze the Q codes, it can recommend efficiency improvements, examine bottlenecks, and compare different strategies. So let me go ahead and try to get some help on efficiency improvements. As you can see, it generates a prompt, and the idea is that once it analyzes it, it will actually create a Miro doc with a recommendation here. So it added all of the objects that I've selected as a context. It'll take probably about half a minute or so to analyze all of that and start generating the recommendation.
That's a lot faster than I could do that, Michael.
For sure. And yeah, let me pray to the demo gods that it actually works. I'm joking, no, it should work. And like I already said, anybody, it's openly available in Miroverse, or when you start a new board in Miro, you typically get a pop-up that offers you to select a template to start from. If you go in and just type value stream mapping, and choose from the AI-assisted templates, you will basically find that template there. Okay, so it created the doc and started to generate.
I was quite impressed when I started doing this, and then we started working with an engineer named Kate, and she began to work on this Sidekick. So I took the same idea and I started writing up, my definition of explanation and my own executive summary, and running it through different AIs on my side. I think hers actually is better than mine. So the Sidekick you're going to get is actually probably a better Sidekick than the one I came up with.
Yeah.
Go ahead, read it on.
Yeah, so as you can see, it created the executive summary. I can now have an option to discard and repeat, or just add it to Canvas. So I've edited it. So now we have the artifact that we can go through, where it basically analyzes the system performance. And you can also see the summary here. So it reveals a critical insight. Your system has an efficiency of only 0.024%, meaning that 99.976 of the 31-day lead time is spent waiting in queues rather than doing actual work, which is terrible, obviously. And of course, we put in these numbers just to illustrate the idea. But in reality, you will likely be shocked by the real numbers once you plug in the numbers from your environment and from your delivery process. So it identified the bottleneck. It went through the, yep.
I was going to say, if you do this and it tells you you're only 6 or 7% efficient, don't be shocked and don't feel bad. That's not that unusual.
Right. And yeah, it has some practical recommendations, such as improve quality gates so that the process doesn't take too long, and actually the rejection rate is probably higher upfront, and we can spend less cycles in the system. Reduction or limitation of the work in progress. This is, I think, this is one of the fundamental recommendations that I've been giving to the teams for many years now, because we tend to spread our efforts too thin typically, and usually that leads to a massive load on the system and a lot of dependency management. And then, of course, combining the steps and removing handoffs, that can also be quite impactful. So yeah, that's a quick demo and a very basic example. I would encourage you all to really go and try that template. You can, of course, modify it to your liking. You can completely map out your custom process exactly the way it is in your organization. Just plug in the numbers and let the Sidekick do its job. It can even work with not just with the Miro content here, but feel free to drop in your existing value strip map and just select it as a piece of context for the Sidekick, and then it will be able to analyze that as well. So with that,
as we know,
I believe we're,
as we know, and of course, it's going to come up with answers based on its rules. It's still your job to go find out if it's telling the truth, if it's correct or not. But you might be surprised how close it is to the truth to begin with.
Agreed. Great. Well, thanks, Tim. I think we are at the 15 or 45 minutes mark here, which is the time to start the Q&A. And I would really like to invite Christina here.
All right, so thanks for submitting questions, guys, into the Q&A. Please keep doing so throughout this. Like Michael said, we have 15 minutes for a live Q&A. A really quick note, we realized that when the video demo was playing, the sound was not streaming. So we have dropped the link to the YouTube video in the chat, and I'll also be including that YouTube video link in the post-event email as well, and adding it to the related content sections for your on-demand webinar console. So do not worry, just because the sound was not there today does not mean that you will miss out on the sound and audio that went with that demo entirely. All right, let's dive into some questions. What are the key criteria for each phase, and how do you move from discovery to defining to delivery?
Sounds like yours, Michael.
Yes. So as I mentioned, essentially, we call it simply the ways of working, Miro ways of working, right? And so we use Miro to build Miro, and that means that we use quite a few features of few tools within Miro at every phase, right? So for discovery, we use, for example, Miro Insights, which allows us to understand the sentiment from our existing user base. We can also plug in the user research in there. And from that, we get the actual insights and recommendations around that problem space. Then we also have internally, our knowledge base is instrumented with internal MCP servers. So through that, we also can quickly extract the specific non-functional requirements and platform limitations, and then combining all of that into a Miro spec, which is what you saw in the video, and unfortunately didn't have sound, as I realized just now. But through that is basically how that context is passed over to the AI code gen tools, and that is the delivery phase, how we call it.
All right. So next question is, as a release train engineer over many ARTs and teams in Jira, what is the best way to use Miro to keep me organized, or at a minimum, sane?
That's a great question. I think tool is only part of the answer here, right? It's really the people, process, and tools. But speaking of Miro, how it can help. So we use Miro tables to maintain the portfolio and the roadmap, essentially. In those tables, we've instrumented different phases of our ways of working. So we know exactly which initiative is at which stage at the moment, whether it's kickoff, solutions review, or pre-release review. We also have the enterprise requirements overlaid on top of that, which means that at every phase of an initiative, we know exactly what the requirements are for different release segments. So, for example, for private beta, there is obviously a very limited set of requirements. For public beta, it increases. Before it's completely enterprise ready, we need to make sure that there is a full host of requirements, like obviously localization, accessibility, all of the other things that are important to make it truly enterprise grade. And all of that is instrumented in Miro, so people know exactly at which point what is required, and there's also automation that that integrates that with other systems like Jira, so that when there are tasks that are handled by the development teams, that status is automatically reflected in Miro as well. So I would suggest basically explore what's available in Miro. Look at the tables and maybe tools like Miro Insights. Well, Miro Insights, I guess, is less for delivery management, more for the inception phase, but specifically tables, integration with Jira and other tools, and yeah, just basically instrumenting the ways of working with automated templates and AI assistants is what really helping us.
Great. Thoughts on using definition of done needed to ensure you have all requirements met?
Sorry, could you repeat the question, please, Molly?
Thoughts on definition of done needed to ensure you have all requirements?
Right. So that is what I briefly showed. There is a checklist for the kickoff phase, for example. We have a similar checklist for every single phase in the ways of working templates, which means that this is basically our definition of done. And I agree that it needs to be there. It needs to be automated as much as possible when possible. Human element of that as well, because it's not just about following the process, but it's also actually people talking to each other and making sure that there's real communication happening.
And then how did you calculate the production lead time in your example?
Tim, do you want to take it?
Yeah. So your production lead time, well, of course, the best way to measure your production lead time is to actually just measure the time from the time it's greenlit until you actually have it live in production in users' hands. But you can get a good semblance of that if you take, this is starting from beginning to end. So the time it enters the queue, the time it takes each of the queues to drain, which is the cycle time of each one of the processes, times the queue population, right? So if you put all that time together, that gives you your lead time. It does calculate it out. So I'm going to spend 3 days waiting to be picked up. I'm going to spend 3 days in development. There's 6. I'm going to spend 5 days waiting for the next stage and 1 day getting done. Okay, so there's 6 more days. Then I'm going to spend, so the ideal lead time would be ignoring the queues. So the ideal lead time is if it took 3 days of programming and a day of review and 3 days of testing. Well, that's easy. That's 3 and 1 and 3. That's easy to work with. But you're going to be disgusted when you see how much of the time is actually consumed in queues, because you may find that all of the actual time you spend doing the work, most of your lead time, you might have 10% of it in actual work. So yeah, just calculate it that way. Just queue times cycle time, queue plus queue times cycle time, plus queue times cycle time, plus queue population times cycle time equals lead time.
Right. So there is a name in this next question, and so I'm going to preemptively apologize if I pronounce the first name wrong, just as a blanket apology. Is reading the book The Goal from Eliyahu Goldratt a good advice to start understanding the flow efficiency topic? And then
Absolutely.
The second question, is what is your preferred book regarding flow efficiency / theory of constraint / lean management in general?
Well, there's of course, everything by Goldratt is good on theory of constraints. And he's absolutely right. And when you look at it, it's always going to be the biggest queue near the end of the process is going to constrain everything. And his process, where you elevate and you, limit everything to the speed of the bottleneck, all of those things he says are absolutely right. You'll get a similar thing from the book Accelerate, which a lot of people find more accessible. But I think that the goal or critical chain, either one of those is great. and those are good places to look. If you are mathematically inclined now, Don Reinertson's Principles of Software Development Flow will take you much further and much deeper, and you will understand why all of those other things work to a much, to a new level. So if you are mathematically inclined, that's a great book, Don Reinertson, Principles of Software Development Flow. If you're not very mathematically inclined, bear with it, it's still good.
That is great advice because I am certainly not mathematically inclined. All right, next question. For the value stream metrics, how much time do you go back to measure, i.e. a month, a quarter, etc.? And how often are you going back through the VSM to see if there are improvements or setbacks?
That's great. So anything you do that improves it is going to show up in your DORA metrics. So if you're doing those now, you should have those continuously. There isn't a good time to stop and do DORA metrics. You should always be doing those. So with the value stream map, making it's the hard part because you have to interview everybody and you have to measure a bunch of stuff. So you'll measure your current state and you'll find out what your situation is and how long it takes. You're probably going to look at that and then start to make adjustments, right? So when you make an adjustment, monitor your lead time and monitor your escape defects because you can cheat. If you lower your standards, you raise your pass rates, but you also raise your escape defects, and that's not so grand. So you want to constantly monitor the lead time and watch new things that have entered the system. By the way, you'll notice with that the best way to get rid of a queue is to combine two stations. So instead of writing the code over here and then testing it over here, if we could code and test it together, if we could maybe pair developers and testers, it still may take longer from coding to the end of test as far as the active time, but it eliminates a queue. And by making code that the tester and coder have worked together, it's going to pass through already by the time they commit it before it ever gets merged in. You will have eliminated a queue. You may have cut out 3 days of processing, but now development takes 2 days instead of 1 day. Great. We lost 3 days by combining them. So you should always watch that. And again, use theory of constraints. Find the bottleneck, make sure you're working at the speed of the bottleneck, and then look at a way to improve that. And if one of the ways is by raising the pass rates or eliminating that stage entirely, the need for it, then you're going to come out way ahead. If you, out of curiosity, I've done this where we took a team that took 120 days to deliver. We got it down to 4. But that 4 days was almost entirely programming and testing time, all worked together. People worked in mobs. So it was 3 or 4 or 5 people working on a problem at once. But delivery was in 4 days because of it eliminated all of that wait.
That's quite a drastic decrease in amount of time. I'm, like I said, not mathematically inclined, so I couldn't tell you what % decrease that is, but even I know that's good.
Yeah.
It looks like we have time for one more question. What is a good signal for rejected in a pull request? They are usually kept open until done.
Oh, so that sounds like a cycle time question. So are they asking about the pass rate?
I think, Tim, if I can maybe suggest here an idea. I believe maybe we're talking about the number of pull requests that are approved in the first iteration, right? So if it gets rejected, then that means that it basically goes back, even though the pull request itself stays open until it's fully approved and merged. But the number of cycles it takes, that's essentially what is important here.
Yeah. So you want to make sure things don't have to be rejected. They should be kept open till done, by the way. That is correct. But measure how often. I did this once. We did this with sticky notes. By the way, you can do this in Miro. It's not a problem. for a given story, put up a little note of when it was rejected and connect that to the story. You know, if you're using the flow board that way. And then mark when it was completed the next time. Keep track. One time I found a team where the round trips through QA, because they had to wait for environments to be prepared, there was a lot of stuff. The round trip to QA and back on a rejection was a 5-day trip, 5 business days. And when we started tracking and counting, we found out that the average job cycled through QA 12 times. 60 business days just round tripping through QA after they thought it was done. So keep track of that. Do keep it open, but, you know, make your notes, see if you can find a way to track what's your pass rate, you know? So if you're rejecting 70% of them, that's pretty bad, right? Something needs to be improved in the coding side to meet that standard. And then also, how many times does it bounce through? Because every one of those round trips is going to cost people time. And again, you know, it's artificially low. You want your testers to be finding defects. Otherwise, how do you know that they're good testers? You want your reviewers to be finding problems. Otherwise, how do you know they're really reviewing? But then, you know, can we find a way to raise those pass rates without lowering our standards? And one of the ways is the people who are going to review the code, have them work on building the code with other people so that we write the code that will pass automatically. When we're done with the code, it's done. But get the testers in. Now there's no queue. When we are done, it passes all the tests and it passes review, and now we can push it on down the line. By the way, that's why pair programming and mob programming work, because it eliminates queues and waits and rejections. And those cycles are what kill you.
All right. Well, it looks like we have reached our time for today's webinar. So I first want to give a huge thank you to Tim and Michael for a wonderful, insightful presentation. We really appreciate you guys taking time out of your days to be here for this webinar, as well as a huge thank you to Miro, who is our mission sponsor for the year. We've done some really great content collaboration, and we're so excited to continue empowering all of our Scrum Alliance members and members in the Agile community with tools like Miro. And a huge thank you to everybody who joined us for today's webinar as attendees. We very much appreciate the time you take to come to a webinar, taking time out of the middle of your day or joining us in your evening. It means a lot to us, and we love being a part of your Agile journey. Just a couple reminders for you. That video demo that was in the middle of the presentation that we didn't get the audio to stream on, we will have that link for you in the follow-up email with the on-demand recording. You will also get that email most likely tomorrow, as long as everything goes smoothly with the processing. And in that email, if you're a Scrum Alliance member, there will be a link to auto-claim your Scrum education unit for this webinar that goes towards your Scrum Alliance membership and certification renewal. I think that is it for my reminders for today. Thank you so much for joining us. We really appreciate it. And if we don't see you before the end of the year, have a lovely holiday season and great end to 2025. Thanks, everybody.
Thank you.